This session of video, we will extend the GCD Greatest Common Divisor algorithm from template function to Variadic template. In our previous video, we learned something like this. Template, type name, T1, type name T, T, GCD, TA, TB. To calculate two greatest common divisor of two numbers using Euclidean algorithm. In this video, we will extend to Variadic template like this. Template type name T1, type name T2, then type name three dots, ellipsis, then types like this. This is called template clause. Then we will create a function like this, auto. We can say auto or T1. I will just say T1 for the time being. T1, then GCD, T1A, T2B, then types, AIGs, then we create functions like this. This is called Variadic template. We use variable number of arguments, variable number of template parameters, and variable number of call parameters. We use like this. This is called Variadic template. Variadic templates. More correctly, this is called Variadic function templates. Okay. So in this case, we can define another function, template, GCD, type name, template. I will delete this. Template type name T1, type name T2, T1, GCD, T1A, T2B, then we implement. Please note that this GCD has the same function name, but different number of template parameter, different number of call parameter. This is two parameters, this is two and more parameters. So these are called function overloading. Function overloading means function names are the same, but can have different types and different number of arguments. Since we are using template function, so we can say function template overloading. Okay, in this session of video, we will be talking about function template overloading using Variadic templates. In next session of video, we will talk about class template, and also type function. In next video, we will be talking about the class template, and also type function. the concept of type function is very important in template metaprogramming. Now I will move to my desktop and I will implement this code. Please note that this video continues from my previous video. This is third video of this series. Please, if you haven't watched my previous video, please watch second video. This is the code we used from previous video. Now unselect all files here, or you can click this one, unselect, then click this button. Then we say O3 Variadic template like this. Create one file. I would say Variadic GCD Variadic CPP. Okay. Instead of copying, I will implement from scratch. Then include utility like this. Now we are creating type name T1, type name T2. We have to return. We can use T1, for example. We can use auto, keyword auto, but I will save auto for later videos. For the time being, we will use T1, GCD, T1A, T2B. As before, T1, I would say R, Y, R is A modulo B. Here, A equals B, B equals R, return B. Okay, or I can say B, T2, because T2 is B's type. I would say like this. And here we should remember one thing. If A, B, A is less than B, then we have to swap std swap. Don't forget this step. Also note that A should be greater than B, greater than or equal B. And also note that A times B should not be 0. I will talk more about this in future videos. So we created a GCD, Euclidean algorithm. Now we will test it before we expand to Variadic template. std cout I would say int A6. We now use short int b 15 gcd a b GCD A B SDE and there. Now save and build. Sorry. I will pin it here. Here, dir cd O3 Variadic template Now I will use CR, EHSC, GCD, Variadic, CPP, FE, G, EXE. There was error here. Now let's go back. It causes trouble. Now let's try with GNU compiler. G++, GCD, Variadic, CPP, or GEXE. STD swap. Because these are of different type, because of different type, it causes trouble. Now let's try it. Let's try with same type, then try it. Okay, it works. Because when we use different type, short int, it causes trouble. It doesn't compile. When we use the same type, it works. Okay, so we will address this issue in future videos. Now I will implement it into Variadic template. I will copy it here. Now I add one more type name, types. This is Variadic template. Now here, types args. Then we can call like this, GCD A, GCD here, B, then args, like this. Then it should work. Now let's try intc 3 times 5, 7, for example. We add one more, C, then C. Let's compile and let's build and try. I made mistake here, I guess. Okay. Okay, it works. It works. But if we disable it, it doesn't work. We disabled this part, this Variadic template, this part, we disabled them. It doesn't work. Try again. No, it doesn't work. No, it doesn't work. So this is base part when arguments are 2. So this GCD and GCD Variadic template is overloaded with non-Variadic template. This is Variadic template. Non-Variadic template. These two are overloaded. So this is basically Variadic template. It seems to be working, but let's try with the GNU compiler. GCD, Variadic, CPP, or GEXE. Wow, it doesn't work. Let's double check. With Microsoft C++ compiler, it works. With the GNU compiler, it doesn't. The problem is that GNU Microsoft compiler doesn't conform C++ standard much. We have to change it to like this. We have to move, copy, paste like this, then save it. Now try again. Okay, now GNU compiler works and Microsoft compiler also works. So this is because when we use function overloading, these are two functions overloaded. When we call the function here, the function should be already defined. This function should be defined because this function calls this function, especially when it returns. This function returns, this is one argument, then a and b is two arguments. So to call this function, it should be defined. Otherwise, it doesn't work. So function call sequence is very important. Function definition sequence is very important when we overload functions. Here I will change one more. I will remind you one thing more. So in this case, what about if we change it to short? Okay, I changed it short. Now saved and build it again. It doesn't actually build CLS. It doesn't build because it is of different type. We want to ensure that when we call functions T1, T2, these are of same type. I will change it to T1, but it still doesn't make any difference, any changes. About how to ensure T1, T2 are of the same type, about that we will talk in next video. In next video, we will learn about type function. Thank you for watching.